So, hello everyone. Today we start the new topic in ionic equilibrium, that is buffer solution. So, actually, it is exactly related to the acids bases. So, what a buffer solution means? The solutions which resist the change in their pH. Which resist means which opposes the change in their pH by the addition of some amount of acid, or by the addition of some amount of base, or even some addition of some any other solvent, nothing but on dilution. Okay, means for example we know that an acid is there which is having pH equal to 5. Okay, so we know that pH equal 5 means it indicates it is an acid generally. Okay, if you add some acid, if we add a few drops of a strong acid, we know that its acidic strength increases, means its pH value decreases. Okay, so if you add some base, if you add a few drops of a strong base addition, automatically its acidic nature somewhat decreases. Means generally for normal solutions, for acid solutions or base solutions, if you add some amount of acids, their acidic character increases, so automatically pH value changes. Even for a basis also, if you add any acid or base, means here for a solution, just we are taking a solution which is having pH value, some any pH value. If you add some amount of strong acid or some amount of a strong base, there is a change in the acidic nature or basic nature. Now acid add cheste somewhat acidic nature increases, a base add cheste somewhat basic nature increases. So acidic nature basic nature lo difference vachindante automatically there is also change in pH value. But some solutions are there which retains their acidic and basic character perfectly, even by the addition of few amounts of, not super liters of amounts added, like a few drops, few amounts of acid addition, few amounts of base addition, even water addition kuda there is no change in their pH, acid kaavachu base kaavachu. So that type of solutions means, simply we can define that the solutions which reserve their pH, or which resist the change in the pH by the addition of a few amounts of strong acids or strong bases or any solvent, they are known as buffer solutions. Okay, it is a very important concept, even in the industries, even our biological system, our body system is also having many buffer solutions. For example, proteins also best example for simple buffer solutions. Amino acids, okay, many number of enzymes, hormones are also works as buffer solutions, because uh, to get good function, so అవి పర్ఫెక్ట్గా వర్క్ చేయాలంటే, సో దే pH మస్ట్ బి కాన్స్టెంట్. సో pH చేంజ్ అవుతుంటే ఆటోమేటిక్గా దట్స్ కాల్ హార్మోన్స్ ఇంబ్యాలెన్స్ కూడా అవ్వచ్చు. సో దట్స్ వై దే మెయింటైన్స్ ద కాన్స్టెన్సీ ఇన్ దేర్ pH. Okay, means they are also examples for buffer solutions. Now we write the definition. So what is the pH means? The solutions which reserve their acidic or basic character, or basic nature, are, okay, write under the definition. So the solutions which resist change in the pH even by the addition of few amounts of a strong acid or strong base or on dilution or adding any solvent. So the solutions are called buffer solutions. Means that the solutions which maintains a perfect pH. Perfect pH maintained చేస్తుంటే their acidic nature is constant, nothing but basis is their basic nature is constant, but it is applicable. So we define this is only for that by the addition of few amounts of acid or base only. So large amount of acids bases dilute cheste, so automatically any solutions pH will changes. Okay, next we see types of buffer solutions. So now we see the types of buffer solutions. So there is a mainly two types of buffer solutions are there. So there are buffer solutions are classified into two types. So the number one, acidic buffer solutions. Acidic buffer solutions, and the second one, simple, it's a basic buffer solutions. So here there are also some other type of buffers are there, just like proteins, amino acids, which are having the only one type of the compounds. They known as generally simple buffers. Okay, it is not a main classification. The main classification is based on the compound present in it, that is acidic buffer and basic buffer. Now we see what are acidic buffers and what is the working of acidic buffer. Okay, now we see about acidic buffers. So acidic buffer solution. So what are acidic buffer solution means? So here important is generally buffers are made up of two components generally, but which are having only single type of molecules, they known as simple buffers, which are having only single type of composition, they known as simple buffer, just like protein solution, amino acid solution are treated as simple buffers. Here what is acidic buffers means? So the buffer solutions which are prepared by the addition of nothing but by the mixing of weak acid. So here we can write so buffer solutions formed, buffer solutions formed by mixing a weak acid and the salt of it. The salt of it formed with a strong base. It's important. Works as acidic buffer. Here see, the buffer solutions the formed by mixing weak acid, by mixing a weak acid and the salt formed with a strong base works as acidic buffer. So here important, it is having two components, a weak acid and also a salt formed by it with a strong base. We know that generally salts are formed in acid base reactions. Okay, means మనం ఏం యాడ్ చేయాలంటే ఒక వీక్ యాసిడ్ యాక్చువల్ ఇవన్నీ మనకి బఫర్ సొల్యూషన్స్ వీఆర్ ప్రిపేరింగ్ ఇన్ ద ల్యాబొరేటరీ. హౌ వీ కెన్ ప్రిపేర్ ద బఫర్ యాసిడిక్ బఫర్ సొల్యూషన్స్ అంటే just take an weak acid is mixed with another component, another solution. What is that solution means? That is nothing but the salt solution. The second solution is the nothing but the salt solution which is formed by this weak acid with a strong base. Okay, so by taking example it becomes very easy. So see, just take an weak acid, that is acetic acid is a weak acid. Next, add a strong base, so add a salt formed by it with a strong base. See here, acetic acid. So acetic acid is a weak acid. Okay, here weak acid is mixed with the salt. So what is the CHCONA? So actually the sodium acetate, CHCONA salt, actually is formed by, how it is formed means just variety reaction for it. When the weak acid react with a strong base, that is sodium hydroxide. So acid base, we know that salt and water, so HOH, H plus released from water, OH minus released from base, and the formation of water. What is the remaining, the main compound? CH3CO minus Na plus. So it is known as sodium acetate. This is a salt. Means this mixture, what is that mixture? The mixture of weak acid, weak acid and the salt formed by it with a strong base. This mixture works as a acidic buffer. Okay, we can write some more examples. Means to identify the acidic buffer or a basic buffers, we must know about the weak acids and weak bases. Okay, acid is weak or stronger, we have to remember. Okay, so on practicing and just listening the total lesson, we are able to know which is strong acid, which is weak acid or bases. Now we see one more example. So here identification of examples is very important in the questions. See, we had one more example. Here HCN is a weak acid. HCN is a weak acid. So the mixture of HCN, KCN. So HCN is a weak acid. So KCN is a salt. Okay, salt of that weak acid, nothing but salt of weak acid HCN kada. The salt of HCN formed with KOH. See the reaction, HCN acid when react with a strong base. So there is a formation of OH H plus removed as H2O, and there is a formation of KCN. KCN is a salt formed by the weak acid. So this mixture works as a acidic buffer solution. So already we know what is a buffer solution. So next one more important thing is acidic buffer solution means it is not guaranteed that all acidic buffers are having pH below 7. Some acidic buffers are also having pH more than 7 also. Means normal pH scale is perfectly not all times works for buffer solutions. Okay, because it depends on not only a single solution, only weak acid paina depend avadi kada. It depends on the concentration of this acid and also this salt. Okay, that's important. We see the working of acidic buffer. So working of acidic buffer solution. So here what is meant by working of acidic buffer solution? What we see in this topic ante మనం యాసిడ్స్ ఎక్స్ట్రా యాసిడ్ ఆ సొల్యూషన్కి ఎక్స్ట్రా యాసిడ్ యాడ్ చేసినా దెర్ ఇస్ నో చేంజ్ ఇన్ ద పీహెచ్. సో యాక్చువల్గా యాసిడ్ యాడ్ చేస్తే హెచ్ ప్లస్ అయాన్ కాన్సన్ట్రేషన్ ఇంక్రీజ్ అవ్వాలి, దాని యాసిడిక్ స్ట్రెంత్ కొంచెం ఇంక్రీజ్ అవ్వాలి, బట్ ఇట్ ఈస్ నాట్ హ్యాపెనింగ్. నెక్స్ట్ ఈవెన్ బై ది అడిషన్ ఆఫ్ సమ్ బేస్. ఇప్పుడు ఈ యాసిడ్ సొల్యూషన్కి మనం కొంచెం బేస్ యాడ్ చేస్తే సో ఈవెన్ దెర్ ఇస్ నో ఇంక్రీజ్ ఇన్ ద ఓహెచ్ మైనస్ అయాన్ కాన్సన్ట్రేషన్స్. ఓకే, అంటే బేస్ యాడ్ చేస్తే ఆటోమేటిక్గా ఏమవ్వాలి, ఓహెచ్ మైనస్ కాన్సన్ట్రేషన్ ఇంక్రీజ్ అయ్యాలి, నథింగ్ బట్ దాంట్లో ఉన్న హెచ్ ప్లస్ అయాన్ కాన్సన్ట్రేషన్ కొంచెం డిక్రీజ్ అవ్వాలి, బట్ ఇట్ ఈస్ ఆల్సో నాట్ హ్యాపెనింగ్. దట్స్ వై దే ట్రీటెడ్ యాజ్ బఫర్ సొల్యూషన్స్. సో హౌ దే ఆర్ వర్కింగ్, హౌ దే ఆర్ మెయింటైనింగ్, how they are reserving their, how they are maintaining their constant in their acidic nature or basic nature. So now we see with help of an example. So with help of an example only it will be explained. So but take an example, CH3COOH and CH3COONA. This is the best example for buffer solution, acidic buffer solution. And we know that it is a weak acid plus this is salt of that weak acid with a strong base, means it is an acidic buffer. We have to so just how to identify it is a acidic buffer అంటే దాంట్లో వీక్ యాసిడ్ ఉంటే అది acidic buffer. దాని pH వాల్యూ కూడా మనకు తెలవాల్సిన అవసరం లేదు, దాంట్లో వీక్ యాసిడ్ ఉంటే నథింగ్ బట్ ఇట్ ఈస్ అన్ acidic buffer. సో ఫస్ట్ we see case 1. So by the addition of, so దీనికి యాసిడ్ యాడ్ చేసినా కూడా there is no change in the H plus. So base యాడ్ చేసినా కూడా there is no change in the OH minus. Why? How it takes place? We see here. So by adding H plus, actually మనం ఒక strong acid యాడ్ చేస్తాం. Okay, if strong acid is added, a few amounts of, not a large amount, if a few amounts of acid is added, what happens? Acid, generally acid ఏం ప్రొవైడ్ చేస్తుంది? So acid provides H plus ions. So the whatever the H plus ions are supplied to the solution, అంటే ఇప్పుడు ఈ బఫర్ సొల్యూషన్కి, సో ఈ బఫర్ సొల్యూషన్కి స్ట్రాంగ్ యాసిడ్, a few drops of strong acid యాడ్ చేసినాం, few drops of strong acid వేస్తే what we expect? సో యాసిడ్ జనరల్గా హెచ్ ప్లస్ రిలీజ్ చేస్తుంది, సో ఇంక్రీజ్ ఇన్ ద హెచ్ ప్లస్ మనం ఎక్స్పెక్ట్ చేస్తాం. ఇంక్రీజ్ ఇన్ ద హెచ్ ప్లస్ అయితే ద యాసిడిక్ సమ్ వాట్ ఇంక్రీజెస్. సో యాసిడిక్ స్ట్రెంత్ ఇంక్రీజ్ అయిందంటే pH వాల్యూ డిక్రీజెస్, బట్ ఇట్ ఈస్ నాట్ హ్యాపెనింగ్. అంటే మనం ఎక్స్ట్రా యాడ్ చేసిన యాసిడ్ వల్ల ఫామ్ అయిన హెచ్ ప్లస్ వేర్ దే వెంట్, మనం యాడ్ చేసిన హెచ్ ప్లస్ అయాన్స్ ఏమైనాయంటే, సో ద ఎసిటిక్ యాసిడ్, ద ఎసిటిక్ యాసిడ్ nothing but the acetate ions of this salt, the acetate ions of this salt, the combined with the H plus forming again acetic acid of same strength. సో అంటే నువ్వు ఎక్స్ట్రాగా యాడ్ చేసిన స్ట్రాంగ్ యాసిడ్ యాడ్ చేసినావు, నథింగ్ బట్ ఏం చెప్తున్నాం దాన్ని, నువ్వు ఎక్స్ట్రాగా యాడ్ చేసిన హెచ్ ప్లస్ అని చెప్తున్నాం. నువ్వు ఎక్స్ట్రాగా యాడ్ చేసిన హెచ్ ప్లస్ మొత్తం దే ఆర్ టేకెన్ ఓవర్ బై దిస్ ఎసిటేట్. సో కాబట్టి again it becomes CH3COOH, means now there is no increase in the H plus ion concentration in that solution. Whatever the H plus ions we supplied, it is taken by this acetate ions and forming simple the same strength of acetic acid, means now there is no change in the H plus ion concentration, no change in the pH. Okay, that is simple. Just మనం యాడ్ చేసిన H plus ions అన్ని acetate ion, this is salt means this is acetate plus Na plus, that acetate ions are taken. Now there is no change in the H plus ion concentration. So if few drops of strong acid is added, So what happens? The released H plus, the released H plus are combined with the acetate, and there is no change. And there is no change in the H plus ion concentration. Therefore, no change in the pH. H plus ions in concentration increase avaladu kabatti there is no change in the pH. Okay, so what is the reactions? The added H plus ions of strong acid are taken by this acetate ions, forming same acid. Therefore, no increase, there is no decrease in the H plus ion concentration. Next, see the second case. What happens when you add a strong base, few amounts of strong base add the same amount. Same other solution key. Now we add a strong base, a few amounts of strong base. Now take the case 2. If a few amounts of strong base is added, so what happens? The released OH minus ions, are combined with acetic acid. Actually, the OH minus are combined with the H plus of that acetic acid again. H plus of acetic acid, mainly forming neutral natured water. ఇక్కడ సో ఫామ్ అయిన మనకి స్ట్రాంగ్ బేస్ యాడ్ చేస్తే వాట్ వీ ఎక్స్పెక్ట్. సో బేస్ యాడ్ చేస్తున్నమాట నథింగ్ బట్ దెర్ ఇస్ ఇంక్రీజ్ ఇన్ ద OH minus ion concentration. But whatever the OH minus ions released, they are take over by the acetic acid. acetic acid లో ఉన్న H plus మొత్తం దాంట్లో OH minus యాడ్ చేసిన స్ట్రాంగ్ బేస్లో ఉన్న OH minus తో యాడ్ అయిపోయి న్యూట్రల్ సొల్యూషన్ వాటర్ని ఫామ్ చేస్తుంది. సో వాటర్ ఎంత ఫామ్ అయినా కూడా అక్కడ అసిడిక్ నేచర్ కానీ బేసిక్ నేచర్ కానీ చేంజ్ అవ్వదు. మీన్స్ సో దేర్ ఫోర్ and no change in the OH minus ion concentration. There is no change in the OH minus concentration, therefore no change in the pH of the solution. Okay, so what is the reaction? So the reaction is the acetic acid combines the OH minus ions released by the water, forming CHCO minus. This H plus combined with this OH minus, forming H2O. It's a neutral. So means finally we can conclude that even by the strong amounts of addition of strong acid or addition of strong base, there is no change in the H plus concentration. There is no change in the OH minus concentration. Finally, there is no change in the pH. Okay, but it is applicable only by adding the few amounts of acid or base. Okay, now we see the working of a basic solution.